Welcome back to the Explainer. So you look up at the night sky, right? And what do you actually see? You've got stars, planets, and, well, just a massive whole lot of empty, dark space. Or so we thought. Today, we're diving into something absolutely wild. It's a radical, incredibly compelling framework known as dynamic vacuum theory. And we're going to explore this idea that empty space isn't empty at all. It might actually be this dynamic, shimmering fluid. And if that's true, it means a purely mechanical universe completely rewrites literally the rules of everything we know.
It's a huge question, right? I mean, for a century, modern astrophysics has treated the vacuum of space as, well, exactly that, a vacuum. Just a passive, empty background stage where the actual actors, the stars and galaxies, just sort of do their thing. But what if the stage itself is moving? What if we've been staring at this invisible, mechanical truth hidden right in plain sight, totally missing the fact that space itself is actually a pressurized substance?
To really get why this matters, we kind of have to look at where physics is at right now, because honestly, we've got a cosmic cold case on our hands. The standard model relies heavily on these invisible crutches, things we call dark matter and dark energy, mostly just to make the math work out. But despite decades of searching, they remain totally unobserved. We've never actually seen them. On the flip side, we have dynamic vacuum theory, or DVT. Instead of inventing invisible ghosts to fix the math, DVT offers this incredibly elegant mechanical solution. It just treats the vacuum itself as a pressurized superfluid.
Okay, so here is our roadmap for today. We'll start with a crisis in physics, then we'll look at gravity as a pressure gradient. After that, we hit the geometric bridge, followed by predicting the triangulum galaxy, and finally, unifying the quantum realm.
All right, Section 1, the crisis in physics.
So, physics is currently facing a massive, massive paradigm crisis. Think about it. When we look at how fast galaxies spin, there physically isn't enough visible mass to hold them together, hence the famous missing mass or dark matter deficit. And when we look at the universe expanding, it's accelerating, but for no obvious reason, so we call that dark energy. Plus, to top the whole shebang off, our rules for the very big, general relativity, completely break down when we apply them to the very small, quantum mechanics. We have literally spent billions of dollars and decades of experimental efforts searching for dark matter and dark energy, and we found absolutely nothing. Zip. Zero. Which forces us to ask the hard question: do we need a fundamental rethink?
Which brings us to Section 2, gravity as a pressure gradient. Enter the Galactic Pressure Law, or the GPL. Now, I want you to imagine space, not as this empty void, but as a vast, pressurized ocean of fluid. According to the GPL, gravitational effects aren't caused by mass bending some sort of geometric trampoline of space-time, like we're usually taught. Instead, they are the direct result of hydrodynamic pressure gradients happening within a dynamic superfluid vacuum. In other words, gravity is just fluid dynamics.
So how does this work mechanically? Let's break it down into 3 pretty simple steps. Postulate 1, think of a massive body like our sun or a planet as a drain in a swimming pool. It creates a local pressure sink in the superfluid vacuum, and that physically pulls the surrounding fluid inward. Postulate 2, what Einstein called the curvature of spacetime, is actually just these local vacuum pressure gradients doing their thing. And postulate 3, this entire behavior, from a tiny little particle all the way up to a massive galaxy, is governed by a single scale-invariant constant. Now, take a really close look at the math here. This equation for gravitational acceleration g isn't your standard Newtonian gravity equation. It is formally the Euler equation for an ideal fluid. It perfectly maps gravity straight over to established hydrodynamic math. And that negative sign, it simply shows the direction of the force. It's moving from the high-pressure interstellar space, pushing inward toward the low-pressure massive bodies. It's basically space pushing down the drain. And listen, this isn't just theory on a chalkboard. It actually solves real-world mysteries in our own solar system. For the longest time, the orbit of Mercury seriously confused astronomers because its perihelion, which is its closest point to the Sun, shifts slightly over time. Specifically, it precesses by exactly 43 arcseconds per century. Standard Newtonian physics could not explain this without adding extra clunky parameters. But when you model the Sun as creating a vacuum depression and a rotational vortex in this fluid, boom, you perfectly recover that exact 43 arcseconds per century, naturally, without adding a single extra thing. Absolutely no dark matter required, just pure fluid mechanics doing all the heavy lifting.
Moving on to Section 3, the geometric bridge.
Okay, I really want you to focus on this elegant first principles equation right here. Chi v, pronounced chi v, equals 2 over pi times g. Chi v represents the universal vacuum permeability. That's the single constant governing the vacuum we talked about earlier. But here is what is absolutely mind-blowing about this. That g, that is just standard Newton's gravitational constant, which means dynamic vacuum theory relies on exactly 0 new fundamental constants. It doesn't just invent some new magical number out of thin air to make the math work. It uses exactly what we already have.
So, you might be wondering, where exactly does that 2 over pi part come from? Well, it's pure, beautiful geometry. See, planetary and stellar gravity operate in a 3D spherical geometry. They pull in all directions at once. That's Newton's G. But galaxies are flat, 2D rotating disks. If you actually sit down and do the math to squish a 3D spherical pressure field onto a flat 2D galactic pizza, the geometric ratio that naturally pops out is exactly 2 over pi. It's quite literally just the geometric efficiency of a 3D pressure field acting on a 2D rotating disk. Amazing, right?
Next up, Section 4, Predicting the Triangulum Galaxy.
Let's look at some actual data. We are looking at the Triangulum Galaxy, also known as M33. Now, in standard models, you'd calculate the Newtonian velocity, you'd realize the galaxy is spinning way faster than it should be based purely on its visible mass, and then, well, you just dump dark matter into your equation to fix the discrepancy. But look at the data points for dynamic vacuum theory. By just adding the vacuum pressure bounding contribution that we derived purely from geometry, and doing this without ever looking at M33's data beforehand, mind you, the DVT predicted velocity perfectly, seamlessly matches the actual observed velocity.
And the absolutely crucial point here is this: greater than 95% predictive accuracy. Let that sink in. This framework predicted the rotation curves of a galaxy completely blindly, working from first principles geometry using baryonic mass alone with over 95% accuracy. No dark matter required, 0. This kind of agreement completely rules out coincidence or curve fitting. This is, well, it's a genuine empirical triumph.
Finally, Section 5, Unifying the Quantum Realm.
Remember that crisis we mentioned earlier, how general relativity and quantum mechanics just don't mix? Well, if the vacuum is a fluid, quantum mechanics actually maps perfectly to Bohmian mechanics. Take the incredibly famous double-slit experiment. How do particles mysteriously act like waves? Well, it's not magic. The electrons are literally surfing physical hydrodynamic pressure tracks in the vacuum fluid, which is what produces those interference patterns. And what about Heisenberg's uncertainty principle? Turns out it's simply an epistemic limit. It just means we physically can't measure the vacuum pressure at that tiny scale without disturbing it. And finally, why is gravity so incredibly weak for a single particle? Because at the quantum scale, a particle is immersed in an isotropic fluid. The pressure is pushing on it equally from all sides, so it remains perfectly balanced.
And it gets even better. How does all this build into the ultimate macro-scale mysteries of our universe? For instance, why does time only flow forward? In this framework, the arrow of time is really just a mechanical consequence of thermodynamic, irreversible pressure diffusion, because pressure diffuses from high to low, and it can't spontaneously reverse itself. And what about that accelerating universe that we used to blame on dark energy? Completely reinterpreted. It's merely the vacuum pressure seeking thermodynamic equilibrium across space. There is no mysterious repulsive energy field required at all.
So we've definitely covered a lot in this explainer. From the pressure gradients that pull planets to the pure geometric projection answering the galactic rotation problem, right down to tiny electrons surfing fluid waves. And honestly, it leaves us with a truly profound realization. If our universe isn't actually filled with invisible dark phantoms invented just to make our math work out, but is instead governed by the elegant unified fluid mechanics of a dynamic vacuum, well, what other incredible mysteries are just waiting for us to simply shift our perspective? Think on that. Keep learning, keep questioning, and I'll catch you in the next explainer.